don't know if you can see, but you can actually see the colony of invertebrates that are forming on them.
My name is Jim Lazorchak. This is Michael Griffith. We are in the first phase after retrieval of Hesterdendes out of the lake to disassemble them, and we will be working on a few of these, and then after we disassemble them we'll have to scrape them off to get the macroinvertebrates off of them. The purpose of this procedure is to get as much biomass out of the lake at various locations, background and a contaminated site, so that we can see what the differences are in PCBs. There's 9 plates in each Hesterdende, separated by a plastic washer. This allows for variable spaces in between the plates, because different types of macroinvertebrates, because of flow, will seek different sizes or different spacing sizes depending on the species. This is what we're collecting here. These are chironomids. We have 2 species that we've collected this time, a larger one and a smaller one. This is the case in which the chironomids live in. They form a case and attach it to these artificial substrates. This is the second phase after we retrieve them out of the lake. We're brushing them down to scrape all the macroinvertebrates off the plates. We'll do both sides. This is a new process that was invented by Michael Griffith and Paul Wernsink. It really speeds up the process of getting these organisms off these plates. Once he's done with this side, we're going to flip them over. He'll flip them over, and we'll scrape the other side. And this whole process is Paul's invention. We did each one separately by hand before. Remember, this is site water. We brushed off the Hesterdende plates individually. Organisms are in here, and we're going to consolidate it down by the standard number 30 sieve. It's 600 mesh. 600 micron mesh, and we'll basically reduce this volume. Yeah, go ahead and do that. Organisms will be caught on this sieve. That's why they call them macroinvertebrates. A lot of what you're seeing here, this fluffy material, are actually the nets that they make, or the cases they make that they live in. The mesh has gotten clogged up. What we have to do is move it around so we can get all the water out of it. Concentrate it down so what we get is mostly organisms. And then we'll put it on a tray and sort this and pull the organisms out. What I'm doing is scraping the fine material off the mesh so the water will go through. And you can see some of the red organisms that you saw on the plates. We've concentrated it down. We'll do this for several times till we completely have drained this cooler and gotten all the organisms on this sieve. Then we'll take it and put it in a tray and sort the organisms. It's like that. We're going to separate them out. Some are big, some are small. And our objective here is to collect as many of these as possible so we get a maximum amount of biomass, weight. We're going to need a couple of grams at least in order to get detection limits of PCBs as low as 1 part per billion. It takes a lot of hours to get this done. A lot of hours to just get a few grams of biomass so that we can find out how much PCBs the macroinvertebrates have in this lake. This is just one piece of the food web, a PCB food web we're putting together. To develop sort of compartments of where the PCBs are in this lake. I'm going to put these in cups like this so that if we have other species, each tray will be a different species. From here, now we're going to put them into the jars like this. They're labeled, what site, what date, what replication they are, because we have 2 reps at each site. They're frozen. Then we bring them to Cincinnati, and we're going to run PCB analysis on what we've collected in each of those reps. And that's it.